Hello, good morning. Can we start? Who are not there? Okay, let me know. Can we start? Okay, yes. Ramcharan Nidhish, Lalita, Vaishnavi, Purvik, Sanjana, Amir Kushal, Maithili. Okay, Atmesh. Okay, the last class, yesterday we have done about organic compound containing oxygen, right? Today we'll try to cover three chapters. One is atomic structure, chemical bonding, like I told you yesterday itself. Atomic structure, chemical bonding, and then amines. Okay, so first we'll do amines. Okay, organic will finish, and then we'll do these two chapters. Okay, so you see, oh, this we have done. Ha, this one. This one you do. Question number two. Why it is A, Ramcharan? White is A. Oxidizes. Okay, you see the mixture of H2SO4 and HNO3 we have. Okay, so one of these H2SO4 or HNO3 will act as an acid over here. Okay, so in this case, H2SO4 act as an acid and provides H plus. So this H plus we are getting from H2SO4. H2SO4. And the nitric acid HNO2, I have already told you that this, the structure of this will write as this HO and then NO2 with two lone pair on this oxygen atom, right? So this nitric acid, this lone pair on the oxygen atom will accept this H plus here and it forms H2O plus NO2, which further dissociates and then NO2 attach in any reaction. So like this the reaction proceeds. Okay, so this is HNO3 which accepts H plus from H2SO4. Okay, that's why it acts as an base. Answer is correct, right? Question number 3. Question number 3. Easy, right? Because for tautomerism, we need alpha hydrogen, okay, that can displace from one atom to another, right? So tertiary nitro compound do not show tautomerism because it has no alpha hydrogen. Answer is B, correct. Okay, alpha hydrogen is required. Easy this one. Question number 4. Question number 4. Okay, so I think you have done it properly. Aromatic primary amine is correct. It's a direct reaction, okay? FeHCl, when you have this compound with NO2 attached on it, is heated in presence of ion with HCl, then it converted into primary amine NH2. Right? Option C is correct. Question number 5, you tell me. Tertiary amine. Okay. So we have to get tertiary amine. Aniline is this. Answer is correct. All of you have got it. Aniline is this. And when this reacts with CH3I, then this one of the H and I will combines. Okay, like I told you in amines, these hydrogen are reactive. So this is already one group we have. And when this reaction takes place, HI forms and we get here NHCH3. Again, one more time, if this is react with CH3I, again this H and this I will combine and CH3 will attach with this nitrogen atom. Okay, that's why answer A is correct. Option A is correct. Tertiary aniline will get here. Question number 6. Hello. Okay, now I got it. Got some issue. Anyways, you're getting C, D. See, most of you are getting C, right? Okay. The answer is option B. When see actually NH4HS that you have here, question number 6. NH4HS will form NH3 HS will form NH3 by this reaction plus H2S. Okay, so this is the reaction we have first. And now metadinitrobenzene is nothing but this NO2 here and NO2 we have here. Metadinitrobenzene. So in this, when this is heated with NH4HS, which gives NH3 here, so according to that, the reaction proceeds and one of the NO2 will replaced by NH2 and HNO2 forms here. Okay, so NH4HS will convert into NH3 first, and that NH3 will take part in the reaction that will replace one of the NO2 and attach with the ring. So the product will be option B here, not C. Okay, so you must remember this reagent NH4HS will convert into NH3, and that NH3 will replace one of the NO2 forms HNO2, and then NH2 will attach with the ring. Right, question number 7, you tell me. Best reagent for converting 2-phenyl propanamide into 2-phenyl propanamine. Yeah, seventh one is D. Seventh one is D is the best reagent. CO will convert into CH2 simply from that. Seventh one is, I think you have done this question. Okay, 2-phenyl propanamide. If I write down the structure, okay, that also we can practice the nomenclature part. Propanamide first of all, right? So propanamide will be this CH3 CH2 C double bond O NH2. This is propanamide, and it's saying 2-phenyl propanamide. So at the second carbon, second carbon, we'll remove one hydrogen and we add phenyl here. So this is 2-phenyl propanamide. Okay, and with LiLH4 in ether, it converts into 2-phenyl propanamide. So NH2 will get here, CH2 NH2. Right, so the structure will be this CH3CH. This won't change at all, and here we have CH2 NH2. C double bond O converts into CH2, it gets reduced, right? Hence answer D is correct. Option D is correct. So for this one it is option B, and for seventh one it is option D. This one, question number 8. Do you have any class today? Like any one of you? Maths or physics? What about tomorrow, day after? Okay. Okay, fine. No issue. Okay, so eighth one is acetamide is treated separately with the following reagents. Which one of these would give methylamine? Okay, so it's a direct question, right? NaOH with Br2. Okay, so this is the direct reaction we have NaOH and Br2 when you use then acetamide, which is CH3CONH2, converts into CH3NH2. That is the reduced, the carbon chain will reduce, right? The reaction, if I write, the reaction will be this CH3CONH2 in presence of NaOH and Br2, it gives CH3NH2, right? Methylamine. Okay, so one carbon will be less over here. Okay. Okay, so answer will be option B. You see, in this chapter, they ask very direct question. Okay, and it's not that much important. Okay, like we have the organic compound containing oxygen is more important than this. Okay, so basic, if you direct, just you go through the name reaction and all direct reaction, you can do the questions. And J means they ask this kind of question only, direct question. Okay, which one of the following should be most volatile? You're getting A. Why A? What is the reason? No hydrogen bonding possible. In two, no hydrogen bonding possible. What about hydrocarbon and tertiary amine? Tertiary amine is more volatile as no hydrogen bonding is present. Fine. So you can easily differentiate tertiary amine with primary and secondary. But what about tertiary amine and hydrocarbon? Second and fourth one I'm talking about. Because In tertiary amine, there is no hydrogen bonding, and that is also true in the case of hydrocarbon. In CH3, CH2, CH3 also, there is no hydrogen bonding. So the point is here that obviously if you have 1 degree, 2 degree and 3 degree amine, so in these two what happens, amines I am talking about. So in these two what happens, there are intermolecular hydrogen bonding possible, and hence the boiling point will be less here because of intermolecular hydrogen bonding. Sorry, high boiling point. So here we have intermolecular hydrogen bonding, which increases the boiling point. So boiling point will be high boiling point, and hence less volatile in comparison to tertiary amine, right? With comparable molecular masses. Molecular mass must be comparable, okay? And there, we should not have much difference in the molecular masses of these molecules, right? So 1 degree and 2 degree amines with comparable molecular masses are less volatile than 3 degree amine. That is true. All these three compounds must have comparable molecular mass. Okay, but you see in 3 degree amine there is no hydrogen bonding. 3 degree amine and hydrocarbon, which is here CH3, CH2, CH3. In these two, if you see, there is no hydrogen bonding. No hydrogen bonding. Right? So when there's no hydrogen bonding, so what we can say, there is one more thing that we can discuss over here. So with the in on the basis of hydrogen bonding, we cannot discuss because here also we don't have, here also we don't have, right? But what we can say here, that here we have in 3 degree amine we have 3 carbon nitrogen bond. Okay, 3 carbon nitrogen bond, and hence this compound is comparatively more polar. And hydrocarbon is what? Since all the carbon atom is sp3 hybridized, so it is what? It is almost non-polar. Almost non-polar. Right? So in this, when we have polarity differences there, right? So what we can say? We can say the we have dipole-dipole interaction will be there, right? So because of the dipole-dipole interaction, the 3 degree amines will have comparatively higher boiling point, polarity, and then dipole-dipole interaction, which gives 3 degree amine as higher boiling point in comparison to this hydrocarbon, which is non-polar. And high boiling point means what? Less volatile, and hence the hydrocarbon here will be the most volatile compound out of the four. Least boiling point, most volatile compound. Is it clear? So option fourth one is correct. So option B is right here. You were taking the logic of hydrogen bonding, but you have missed for primary, secondary, and tertiary amine, hydrogen bonding is true, and we can easily eliminate primary and secondary. But when you see the hydrogen bonding is not present in hydrocarbon also. That's why they have given this hydrocarbon. Okay, so you have to consider the polarity. Correct? Option B is correct. Next one. Strongest base in aqueous medium. I have done this 10th one is C. Correct. I have given you one more order on this. Right? This CS3 has what? One methyl group and two methyl group. So there is more electron releasing group here. Electron density of nitrogen will be maximum here. Here we have one is electron withdrawing and other one is also electron withdrawing here because of the nitrogen CN group here. That's why C is correct here. Right? 11. Question number 11. Basic strength of the following. Ramcharan is getting B. Saundarya D. Ritvik B. Saimihir D. Atmesh C. Purvik D. Are you sure which one is least in this? Option 1, like this first compound that is given, it is obviously the least basic because here also electron withdrawing. This is also electron withdrawing and C double bond O also electron withdrawing. An electron withdrawing group is decreases the basicity, right? So option, the first compound is the least one, right? So we can eliminate option A easily, right? And now you see if we can compare the next one, next basic compound, because we have here one and one and four, two, three, four, two, three, four. So two, three, four. Next basic compound will be what? After one, see NH2 we have here and C double bond also. It is what? Electron withdrawing group. So electron withdrawing group will decrease the basicity of this NH2. This is what NH2 here. This one is electron releasing and this one is electron withdrawing, but this will not withdraw electron with this. Okay, this lone pair. Okay, in this, can you tell me the lone pair that we have here, this lone pair, Is this involved in resonance with this double bond O? Yes or no? Tell me. Is this lone pair involved in resonance with this double bond O? No, right? No. So that's why here we have only electron releasing group that releases the electron, and this lone pair is still available on the nitrogen atom. So obviously this one has maximum electron density, and hence the basicity of third one is maximum. Here you see this lone pair is involved in resonance with this double bond, right? So comparatively, if you see this group, this group has one electron releasing group, but at the same time, C double bond O is withdrawing electron also. So if you compare these two, here we don't have any electron withdrawing effect on nitrogen. That's why the basicity of third one is obviously more than the second one, right? Third one is obviously more than the second one. So we can eliminate option B also, right? Third is more than 4. Third is more than 4. 2 and 3, if you compare, this nitrogen will not have any electron withdrawing group attached with it. So obviously third one will have more. Okay, 2 and 4 if you have to compare. No, 2 and 4. If you compare 2 and 4, then what happens? Here we have electron withdrawing group on this. This is also electron withdrawing. This is also electron withdrawing. But this one you see, one is electron releasing, another one is electron withdrawing, right? So second one will have more basic than fourth one. That's why option D is correct. Is it clear? Is it clear? Understood? See, one more thing, let me tell you here. Suppose this question you do not know anything, okay? And you want to attempt this question, like suppose you got this, the first one is easier to decide that this one is the least basic compound, right? So when you got this, that first one is the least basic. After that, suppose you are stucking somewhere and you are not able to write down the order of 2, 3 and 4. Then what I have seen so far, like in the questions, that this kind of question, when you have the order, right, when you have the order here, first one is least, right? So 1, 2 and 3, in these three options the first one is least. After that, the most common option is what you see in C and D. Third one is maximum, right? And B, fourth one is maximum. So like I have seen this, that whenever you have options like this, in which the common, you have to take the common options in all the given options, right? So third one is maximum here, here and here. So you can understand that there are 80% or 90% of the probability that third compound, which is this one, is the most basic. Okay, so if you can analyze, suppose one or two options, if you do not know anything, then better you leave the question, right? But if you can understand one of these, that one is least, or this one is should be least, or this one should be maximum, after that if you are stucking, then you just go through the options like what I said. Third is maximum here in the two options C and D. There are 90% of the chances that third one will have the maximum, will be the most basic compound out of the four, right? So like that you can attempt, if you want to attempt this kind of question where you have done it partially, okay? Otherwise, if you do not know anything, better you leave it. Don't uh, guess randomly. Okay, A, B, or C, and D. So that I have seen in many questions. Those kind of things were true. Anyways, question number 12. Some of you are getting B, some of you are getting C. 2 is obviously maximum, okay, which is given in the option. This kind of question I have done. See, if you compare 4 and 5, just you compare these two, 4 and 5. Which one is more basic, 4 and 5? Which one is more basic? Fifth one. So now you see, like, you don't have to check all these four. If you see the option, here the fourth one is greater than fifth. Wrong. Why I ask you to check these two? Because all the option you see, fourth is greater than fifth, fourth is greater than fifth, fourth is greater than fifth. In only one option, that is C, fifth is greater than four. Correct? So if you are able to decide these two, you will get the answer. If if the order you get this, otherwise you can eliminate this and then we can check the other three. Okay, so here you see obviously the oxygen will have more electronegative nature, right? So basicity of fourth one is less than to that of fifth. That's why the fifth one is more, and luckily we have only one option in which fifth is more basic than fourth. I am coming to that, Atmes. First you tell me, first and second, how do you know that second one is more basic? I'm coming to that. Wait, Ritvik. First, you tell me first and second. I'm comparing. How is second is more basic than first? How do you compare first and second? Because here also we have lone pair available, right? It is not involved in resonance, and here also we have lone pair available. Then how do you compare these two? Correct, correct. So that is true in first and second both. In both the compound, lone pair is not involved in resonance. Right? That is true, Vaishnavi. That is true for first and second both. Yes or no? See, the point here it is what? Because the double bond, this nitrogen atom is sp2 hybridized, but this one is sp3. Yes or no? It is more electronegative, so tendency to lose lone pair will be lesser than this. Fine. Is it clear? Okay, so there is no any like they can give you any kind of questions. You have to aware with all these facts, like what all facts you can just you see the difference between the two compound, because randomly there are many logic if you see in the books or in the notes that I've told you, but which logic you should apply, that you will understand according to the options given. So what is the difference in these two? We know that both lone pair is not involved here, it is not involved in resonance. So both lone pair are available on the nitrogen atom. So that won't make any difference. What is the difference we have? The nitrogen atom is sp2 here and here it is sp3. So since it is sp3, less electronegative, can donate the lone pair easily in comparison to the first one. Right? That's why the second one is more basic than this. If you compare first and third, right? That's what Ritvik you asked, right? First and third, right? So third one you see here we have C double bond O. This is electron withdrawing group AWG. Here we do not have any electron withdrawing group. Because of this nature, the lone pair which is here on this nitrogen atom is the electron density will be less here in comparison to this or this. So that's why, because of the nature of this electron withdrawing group, this is less basic. Understood? Okay, next one. 13. All of you are getting D because of what? The plus I nature of this CS3. D is correct. Here we have plus I nature, but this one is minus I. This one is minus I. This one is plus I, but this one is minus I. Right? So answer D is correct. Option D. All of you have got, so I'm not discussing this. Okay. Question number 14. What is the order of primary, secondary, and tertiary amine in aqueous solution? Order, you tell me. What is the order of primary, secondary, and tertiary amine with the methyl group in aqueous solution? What if ethyl? What if ethyl we have 231? Yes, 213 and 231. These two you have to remember. Okay, so option C is correct here. This is important. Okay, you must keep this in mind. Question number 15. Just a second. Hello. Can you call me after 12:30? I will. Yeah. Yeah. Question number 15. 15, you are getting A. This is also a direct reaction, right? We'll get isocyanide, RNC, into this. 15th, A is correct. 16th, why it is C, Purvik? Nitrosoamine forms when H2O evolves, right? And for that we required secondary amine, okay, which is only one option we have, that is diethylamine. So option A is correct. 1 mole of H2O evolved. The reaction is this in this case, you see. C2H5 whole twice NH plus HNO2. HNO2 is nothing but this. HNO2 we have aqueous nitrous acid. So HNO2 is this HO and double bond O, right? So this hydrogen and this OH forms H2O and this NO group attached with this. So the product is this here, C2H5 whole twice N dot N double bond O, right? This is, we call it as nitrosoamine. Okay, this is nitroso group attached with this amine group, nitrosoamine. Okay, so this is true when we have diethylamine secondary amine. So option A is correct here. Understood? Option A. Question number 17. 17th, you are getting D, A, B. Okay. You see the reactions RNH2 reacts with this. So what happens? This hydrogen and Cl forms HCl. So the reaction will be this C6H5 SO2Cl plus RNH2. HCl forms and this RNH attached with SO2 C6H5. This is the product we get in the first reaction. Now this is N-alkyl benzene sulfonamide, and with N-alkyl group is attached. So N-alkyl, this is C6, benzene sulfonamide. Okay. Now when you put on acidification a precipitate of KOH, right, aqueous KOH, so this will form a salt. What happens? Again, this nitrogen, this hydrogen, and this OH forms H2O, and we get a salt over here. And the structure of that we can write R N minus SO2 C6H5 and K plus. This is what we get. So the answer will be what? The answer will be option B, right? Oh no, the question is something else. On acidification, a precipitate is obtained which is due to the formation of. Okay, so we are getting this, no? RNHSO2 CCH5. So answer will be option D, not B. Yeah, it's D. B is the product we get, is the salt we get. But that is not the question. The question is the precipitate which is forming or the salt which is forming, that is because the formation of which compound? It is because of the first reaction we have. So it is D. Understood? Yes, correct. Correct, Soundarya. The salt is nothing but the precipitate. Understood? So they are not asking the precipitate, they are asking the precipitate obtained due to the formation of which compound. That's why it's D. Fine. Question number 18. What happened? Yeah, it's correct. It's a primary amine. How many primary amine we have in this options? Methylene. How many primary amine we have in this options? Correct. Yes, Lohitya. So, so the answer will be either A or D. Answer will be either A or D. Molecular formula is different in this question, you see. A will have different molecular formula and D will have different molecular formula. Correct? And vapor density is given. You check the molecular formula, molecular mass, you check. What is the molecular mass of A? Yes, since vapor density is given, Mathili, so from that we know the molecular mass, right? So you check the molecular mass of A and D, that should be equals to 2 into vapor density. Correct? So option A is correct. So you see how they mix the concept here. First of all, they have given this. What you can do if you actually want to solve this question, but since we have objective, so you know on treatment with nitrous acid, it gives nitrogen. So the amine must be primary amine. That property you know, right? So according to that, you can eliminate option B and C. A and D is left. So with A and D, molecular formula is different. So you find out molecular mass of this and the molecular mass of this. And according to the question, the molecular mass should be 2 into 29.5, which is 59. And only one will give you 59. So we'll get the answer. But this question, you see how they mix the concept of mole concept and amines into this. With these data, you can actually find out the empirical formula of the molecule. Can you find out the empirical formula with this data? Can you find out the empirical formula? What is the empirical formula of this? Why, you see, for carbon, the weight is 61.03. This should be divided by 12. You'll get 5.08. Right? Hydrogen. Okay, nitrogen is given. So nitrogen is what? 23.71 divided by 14. So that will be around 1.69. And hydrogen will be what? 100 minus this, 100 minus 61.03 plus 23.71. That will be 15.26 divided by 1 is equals to 15.26. Now in all this is the minimum value. So this is the molar ratio we have. Now simplest ratio, if you calculate, simplest ratio. That will be whatever the minimum value out of these three we have. From that value, we'll divide all these number to calculate the simplest ratio. So you see, for carbon, the simplest ratio will be 5.08 divided by 1.69, which is approximately 3 we can take. For nitrogen, it is 1. 1.69 divided by 1.69 is equals to 1. For hydrogen, it is 15.26 divided by 1.69, which is equals to 9 around. So the empirical formula will be what? C3H9 and N. Empirical formula mass, if you calculate for this, the mass of this empirical formula, 12 into 3, 9 into 1 plus 14, which is again 59, right? So molecular mass we already know 59. So N value is what? Empirical formula mass divided by molecular formula mass is equals to 1. So since 1 is the value of N, so molecular formula is nothing but the empirical formula of the compound, right? So formula of the compound is C3H9N, molecular formula. And we know this compound is primary amine, 1 degree amine. So we can draw actually two structure of this. Okay, let me just clear it up. C3H9N, we can draw this also, CH3, CH2, CH2, NH2, right? Or we can also draw CH3, CHNH2 and CH3, right? C3H9N, if I ask you DOU of this value, it is 3 plus 1 minus H plus X minus N, 10 minus 1 by 2, H plus X, so it's 9. 9 minus 4 by 2 is 4, 4 minus 4 is 0. DOU is 0. So when DOU is 0, again you see this option is not possible, because for this option DOU value is 1. Is it clear? So there are many methods you can cross check this. We can draw these two structure for which the DOU value is 0, primary amines. And in the option it is given only this one. That's why the option A is correct. Okay, so if you don't have this information that on treatment with nitrous acid it gave nitrogen, if you don't know it is primary amine, then from this data till here you can use the concept of mole concept you have here, and then you can get the empirical formula and you get the molecular formula. So if you have molecular formula, right, so with molecular formula, what you can do, then you can eliminate option D only. So if you do not know this, you cannot do this question. That's the one simple thing. You should know this, that the compound should be primary amine. Anyways, so like this, the two different way you can do. But since the objective question, you directly know that it is a primary amine, so either A or D is correct. Okay. Then you check molecular formula and you can do this. Okay, option A is correct. Simple one. Next, Question number 22. Yeah, wait, I'll do that. 22 is B. Is it B or C? In the first compound, we'll get nitrene or carbene. Yeah, it is C. First compound, first reaction will get nitrines, and the second one will get carbene from CHCl3. What happened? Check. Option C is correct. Let's take B and C option. First carbene and nitrene, but it should be nitrene and carbene. What happened? Samir, Shreyas, Sanjana? See, the first reaction we have is CH3CO NH2. When this reacts with Br2, correct? HBr forms and it forms CH3CO NHBr. When this further reacts with KOH, then KBr and H2O goes out and we'll get CH3 C double bond O N with two lone pair on it. This is nitrines. Okay, this is nitrines. Now in this, what happens? This CS3 will shift to this nitrogen here, and then finally we'll get CS3NH2. I have done this mechanism in the class. I have done this. See, Simon, there's no any confusion. We'll get carbene when you have CHCl3, CCl2 dot we'll get over there. Right? Once you are sure that carbene and nitrine you are getting, then you should not be confused, because nitrine is only possible. I have given you, go through the notes, amines when I have done in the class. I have given there then when, in what cases formation of nitrine is possible. There is one of these cases are there, amide. Okay, you must just revise your notes. Okay, so this is nitrines. After this, what happens? This lone pair comes over here, and CH3, this will go here, and CH3 will attack onto this nitrogen atom. So we'll get CH3's NCO, CH3NC double bond O or O, which on reaction with KOH converts into CH3NH2, primary amines. Okay, so this reaction, first reaction gives you amines, second nitrine, second reaction you see the reagent we have what? CHCl3 plus KOH. This gives you H2O plus KCl. We'll get H2O, K plus CCl3, one unpaired electron, and with this two, it forms finally KCl, and we get CCl2 with a lone pair of electron here. This is nothing but carbene, CH2 or CCl2, carbene. Okay, now when this reacts with CH3NH2, this reaction also you should know, CH3NH2 will get isocyanide, CH3NC. Slight difference we have here, but this reaction is important when we get amines like this, when we get isocyanide like this. Okay, so answer is option C. Okay, question number 23. What is the answer? 23rd, you are getting A. All of you have got A. The main product in the reaction, this NH2OHCH3OCl. So it's simply HCl will go out, right? What happens if you take two equivalent of CH3COCl? What happens if you take two equivalent of CH3COCl? Simply in this one of this H from this nitrogen and this Cl forms HCl, and this COCH3 will attach with NH over here. So option A is correct. Very straightforward question. But my question is, if we are taking here two equivalent of CH3COCl, then what happens? Then another hydrogen also will get replaced by COCH3. Is it true? Then we'll get NCOCH3 whole twice. 2HCl will come out. Yeah, it's correct. So in this question, option A is correct. Next one. This one you do. Question number 24. SO3H will attach, right? At ortho and para position, but para one will be the dominant one or the major product. So the final product here, it will be this. NH2 will be as it is, and SO3H will attach over here. This we call it as sulfanilic acid. Option C is correct. All of you are getting this. Okay. Next, 25th. Oh, sorry. 25th one. 25th is also C. Nitration of aniline also gives M-metanitroaniline in a strong acidic medium, because in acidic medium aniline is present in anilinium ion. Yeah, it's correct. So we'll get what? We'll get ortho product, we'll get meta product, we'll get para product into this. So composition here it will be around 51% para product will get, 47 to 48% will get around meta product, and 2 to 3% will get ortho product here. 47 to 48, 2 to 3, like that it is. Approximately this is the product we'll get. So in acidic strong medium, it is present in what? Anilinium ion, and that's why the meta nitroaniline you also get into this. Okay, option C is correct here. Question number 26. Question number 26. Ramcharan is getting B. Okay, option B is correct. See, I'll write down the reactions. See, first of all, we have toluene. With conc H2SO4, you'll get ortho substituted as well as para substituted product, which is CS3 here, and we have SO3. I'll write down only ortho product here, okay? SO3H plus, this will be there at para position. This is ortho toluene sulfonic acid, okay? Ortho toluene sulfonic acid. When this react with okay, para isomer, when this react with PCl5, then what happens? HCl forms and Cl will attach here. So the product here we get is CH3 will be as it is. Here we get SO2Cl, HOCl forms into this. And the further, if this reacts with NH3, then HCl forms, yes. Then HCl forms and NH2 will attach over here. So the product will be this NH2. After this, you're using aqueous KMnO4. So aqueous KMnO4 will oxidize this CS3, and with aqueous KMnO4 we'll get here COOH, COOH, and here it will be SO2 NH2, right? Further, we are heating this. So obviously, when you heat this, condensation takes place. OH and H plus comes out as H2O, and these molecules combines as CO, NH, SO2, and H. So the product will be option B. We are getting para. Okay, we are using para isomer here. No, fine. Then I don't think product will be this. Para isomer if we use, then we get here Cl, SO2Cl, and then SO2NH2, and COH, SO2NH2. COH, SO2NH2. I think the option is not given then for para isomers. See what happens when para isomers react here, then everything will be there at para position. This will be at para position, this will be at para position. But when you have this COH and SO2 NH2 as para position, after this when you heat, then condensation will not be possible, because at this position we have SO2 and NH2, and here we have COH. Then condensation is not possible in that case. Okay, so that's why I think there is a mistake over here. According to the option I'm telling you, it should be orthoisomer. Then only we'll get a condensation reaction will take place and we'll get this. Understood? Is it clear? With respect to para isomer, the option is not given. Condensation is not possible there. Okay, option B is correct. Next, you will see. See, these are the question asked in J exam. Tell me quickly, can you see this or I should enlarge this, magnify this? 52. We have discussed this already. 52. 52. Admesh and Saimir is getting B. Tell me the answer. See here what happens. Compound with molecular mass this to get a compound molecular mass this, the number of amino groups. Amino groups we have, right? Okay. If you see, it is a acylation reaction. And if I take here RNH2, the compound reacts with CH3C double bond OCl and it forms RNH C double bond OCH3 plus HCl. So you see one hydrogen is getting displaced and CH3CO group is getting attached. Okay, so if you see the mass of CH3C double bond O group is 43, right? And it displaces one hydrogen atom. So with one CH3CO group, like 1 mole of this reacts with 1 mole of this. So with one CH3CO group replaces one hydrogen atom. So mass that has been added to the compound here in the product is 42. Because one is getting replaced and 43 is added. So 42 is the extra mass we are having here. And according to the question, it is given 180 is the mass of this and 390 is the mass of this, right? So with 1 mole, the difference is 42. What is the difference in the molecular masses? 390 into minus 180. That will be what? 210, right? So with one molecule, the difference is this. So for this mass, the number of molecules should be what? 210 by 42, which is 5. So option B is correct. Is it clear? 53 is A, methyl isocyanate. Bhopal gas tragedy, methyl isocyanate. 54. 54. It is the carbylamine reaction. 54th, I have done this mechanism in the class. You can go through. 54. Carbylamine reaction, aliphatic aromatic primary amine via which of the following intermediates? So it is formed by carbenes. The intermediate will be carbenes here. I have done this mechanism in the class. You can go through with your notes. Okay, so I'm not doing it again. Fine. And all of you have already done this. So next one, 55. Can you see this question? A major component of Bosch reagent is obtained by reacting hydrazine hydrate with which of the following compounds? What is Bosch reagent? That is 2,4-DNP. 2,4-DNP is Bosch reagent. Yesterday I have discussed. 2,4 dinitrophenyl hydrazine. Bosch reagent is 2,4-DNP. Write it down. Bosch reagent is 2,4-DNP. 2,4-diphenyl hydrazine. 55th. Yes, 55 is C. Correct, Mathli. 55 is C because hydrazine hydrate is what? NH2 NH2 dot H2O. Correct. So when this hydrazine hydrate, see here, option C I am taking, okay? Because Bosch reagent we know it is 2,4-DNP. That is the information you should have, okay? So we have to form this. The product should be this. I'll write down the structure of the product first. NO2, NO2, and here we should have NH dot NH2. This is 2,4-DNP or Bosch reagent. So this we can form by this reaction. You see, if you have Cl present, this 2NO2 will be as it is, like it is given in option C. Here we have Cl, and when this reacts with hydrogen hydrate. Hydrogen hydrate is this NH2 NH2 dot H2O. So in this, what happens? This HCl goes out and this NH2 NH2 attach over here, right? And the product will be this H2 also will go out, right? So 55th one, option C is correct. 54th, sorry, 56th. 56th. 56, most of you are getting D, which is correct. Okay, because we have to form this CS3 CH2 NH2. And how do we get this CS3 CH2 NH2? You see, if I take this option D, we have CH3 CH2 COOH reacts with NH3, right? And we heat this also. So H2O goes out and we'll get CS3 CH2 C double bond O NH2. We'll get amide here. Plus H2O will go out, right? With the help of Br2 with KOH, we'll get here what? This is Hoffman bromide, right? So Hoffman bromide, what it gives, this R and this NH2 will join, which is nothing but CS3 CH2 NH2, which is nothing but the question we have here. So option D is correct. Okay, 57. The major product of the following reaction. 57. Answer is A. Yeah, it's correct. 57A is right. You see here in this question, see, first of all, the this is the compound we have NH and here we have KOH. This OH minus will take this H plus and forms H2O. So in this reaction, in the first step, we'll get a nucleophile, and that nucleophile is this C double bond O N negative charge C double bond O like this. This compound, which is H plus, is taken by OH. This act as a nucleophile, and this nucleophile will attack on this Br. See, now the question is why? See, when the solution should be this. This negative charge will attack over here, and this chlorine will go out as a leaving group. Now the question is why not this Br leaves as a leaving group? So this is not going out because this Br is in resonance with this ring. The lone pair of this Br is in resonance with this ring. So here we have partial double bond characteristics, which is difficult to break. That's why the Br will be as it is in the compound, and this Cl will go out. So this will joins with this. So you see option A we are getting as a major product. Is it clear? Yes or no? Tell me. Yeah. So option A is correct. Last one you do. Question number 58. Oh, sorry. 58. So all of you are getting B. First A will get what? Benzene disonium chloride, disonium salt. The reaction is of disonium salt, right? So we'll get benzene plus N2Cl over here. Here we'll get benzene N2Cl. So direct reaction, I have told you, this reaction they ask directly. Okay, benzene disonium chloride. With CuCN, what happens? N2 goes out, right? CuCl forms, and this Cn will attach over here. So benzonitrile will get here. The B product will be benzonitrile, Cn will have here. Correct? So option B is correct. Benzene disonium chloride and benzonitrile. Fine. Understood all these? You see, we have discussed mainly probably all types of question in amines. Okay. And if you see most of questions you have answered on your own. So you have prepared it properly, I guess. Okay. And the questions are not tough. They ask only basic questions. Fine. So it's 11 o'clock. We'll take a break for 15 minutes. Okay. And then we'll start atomic structure and chemical bonding. Fine. Right. Okay. See you at 11:20. क्लास अभी खत्म नहीं हुआ ठीक है और ऑनलाइन नहीं है इसलिए बाहर निकलोगे हल्ला मत करना हम ब्रेक दिए 15 मिनट का आपने ब्रेड बंडा लेंगे और के बाद बोलो चप्पल तो चप्पल नहीं है चप्पल नहीं है नहीं है कुछ भी बाहर जूता तो नहीं जाएगा पैंट है दे दे दो दे दो Okay, can we start? Are you there? Can we start now? Okay. Solve this one. First one, what will be the lattice energy of CaCl2 if the enthalpy of sublimation of energy few data are given? Okay. Wait, I will just magnify this. What is the answer? Any one of you? See, enthalpy of what will be the lattice energy of CaCl2 we have to find out. Okay, so for that we required all this data. The sublimation energy of calcium, dissociation energy of Cl2, because Cl2 you have to dissociate, you'll get chlorine atom, and then chlorine atom you have to convert into iron. Okay, and calcium you have to convert into calcium ion. Then only you'll get. Vaishnavi is getting C. Okay, so C is the correct answer. See, for the enthalpy of formation of CaCl2, enthalpy of formation of CaCl2 requires what? The sublimation energy of calcium, excuse me, dissociation energy of chlorine, formation of Ca plus 2, and then the electron gain enthalpy of Cl minus, delta EgH of Cl minus. But since we require 2 Cl minus here, so we'll multiply this with 2 into this, plus overall enthalpy of CaCl2 is this. Delta H formation of this. Correct? So here you see this value is given, all these values are given. This is also given, this is also given. You have to find out the enthalpy of formation of CaCl2. You will solve this and you can get the answer. Okay, the answer you will get is option C. Overall, this is the overall enthalpy change. Left hand side, overall it is given. This you have to find out. All these values are given, you will substitute and you will get the answer. Option C is correct. Right? Question number 2. What is the answer? Why all of you are getting D? See, I have discussed this. There are 7-8 cases for the stability of resonating structure. Do you remember that? I have discussed 3-4 cases of resonating structure. What was the first case? What was the first case? What we'll see first of all? What is the first condition we'll apply? It's not that tough. It's not that tough, Akshay. You can go through the video, it's there online. You can search for stability of resonating structure, it's there, but I'll discuss here. Just 1-2 points I'll discuss here. But if you want to study all those, there's a video called stability of resonating structure. You can go through that. Okay. So the first condition I have discussed was the number of pi bonds we'll discuss, right? Or the number of covalent bonds. More number of covalent bond, more will be the stability, right? The first case was this. So you see here we have double bond, so 2, 4 here. This is 4 bonds. Here we have 3, 4, and then we have 4 here, right? Just a second. Right? So in all these, if you see, this has okay. And see, all these has equal number of, this is 3, so obviously this one will be least, right? This one will be least, right? So if you compare first, third, and fourth, on the first one, the number of covalent bond is 6, 2, 4, 6, 3, 4, 6, 3, 4, 6, right? But here the negative charge is present on the nitrogen, which is more electronegative element. So obviously the first one is the most stable. Right? First of all, we'll see the number of pi bond, number of covalent bonds. Right? Number of covalent bonds, if it is more, stability will be more. So you see, if you compare 1, 2, 3, and 4, 1, 3, and 4 will have what? 6 covalent bonds. And here we have 2, 3, 4 covalent, 2, 3, 5 covalent bonds.